Even we are few people in the room. Professor Marija Todorović forgot her computer in the taxi, and she has a problem now. But anyway, let's start. Can I have a presentation, please? Okay. Yes, that's it. Okay, ladies and gentlemen, thank you very much being in the last session with us. I want to introduce myself. I'm Silviu Dobosi, the president of Romanian Association of Building Services Engineers. My background came from business. I manage a group of companies with 150 employees, which work and who provide design and build works. And I'm ready to present you European project. I was contacted by eSafe Group in Brussels through Riva and to find a pilot building for this project and in that way start our collaboration. What means eSafe? First of all, the project coordinator is Professor Giuseppe Margani from Università di Catania, and the technical manager is Giampiero Evola from the same university. And in fact, you will see eSafe. The table of contents of my presentation is divided in 4 chapters. The first one is general description of the eSafe project. The second one, structural solution for seismic resistance and building envelope performance. The third chapter is energy solution for more efficient building services, HVAC, plumbing, electricity, and co-design process for a pilot project, one of the most important idea of this project. In fact, energy and seismic affordable renovation solution for the EU building stocks. It's a holistic approach, and we can cover different fields. The first and the most important is the seismic energy performance improvement of building. The second one, architectural improvement, reduction of the environment impact of building, reduction of cost for renovation and work, financial tools, demonstration, training professional, social issue analysis, and minimize disruption. The main technical goal for this project, taking in account the non-historic buildings with reinforced concrete structure for seismic and energy and architectural renovation, it's to develop a solution cost-effective, low-invasive, and environmentally sustainable. In fact, eSafe is a consortium of 12 partners from 8 EU countries, and the duration of this project is from 5 years. We have 1 more year until 30 of September 2025. The concept for the new seismic resistant energy efficient building envelope consists in the different panels. The first one, ACLT, structural and insulating prefabricated panel made of cross-laminated timber. The second panel, E-panel, insulating prefabricated wood-based panel, integrating new windows that replace the existing ones. And E-exos, it's a structural steel exoskeleton connected to the existing structure and combined with the E-panel. the group and the consortium tried to find pilot buildings, and it was selected one pilot building from Catania and two buildings from Romania, taking in account that Romania is a seismic area with very, very important level of calculation for this point of view. It's clear to have an energy performance renovation for a building. First of all, we can take account about the structure of the building, and if structure gives this possibility to support and to be a safe building, after that we can think to renovate from energy performance of building. That means, once again, the first one is the Catania block of flats. You see here the current states and the post-renovation states of the building. The next one, it's a block of flats from Bucharest. You can see the current state and the post-renovation state. It's a simulation. It's not yet realized, but it's a simulation. Looks very nice. And the third one, it's the High School Banatul from Timișoara. Here it's also, let's say, I am very close for this building because it's my high school. My high school. I promoted the high school in 1881. It's a sport high school, and I play handball more than 50 years, and we find that a very good reference for this project. And we have the current states of the building and the post-renovation states all of the building with different aspects. Related with the energy performance conception, we have thermal system with even minimum energy demand. Each term is supposed to have high performance air to water electric heat pumps, insulated water tanks to store thermal energy, full DC inverter technology, refrigerants with low GVP will be preferred, fine coils fed at low medium temperature, less than 45 degrees Celsius. Also small storage tank for domestic hot water, 140 liters, and floor heating if it's necessary. And we can see how we can integrate the systems together with structural system and the energy performance of building with thermal solution for a building. The e-safe impact, it's a contribution to building decarbonization. From non-renewable primary saving at building scale, the Italian pilot buildings, it's between 19 and 95%. For Romanian pilots, it's between 70 and 75%. The reason it's the harsh climate imply lower COP and PV electrical production in Romania. From time reduction for renovation work, it's 40 to 45% in case of combined seismic and energy renovation. Impact on the EU building stock to be validated after the implementation and the finalizing of the work. The collaboration with Romanian Association it's to check how this solution can be applied accordingly with our new methodology regarding the energy performance of building. The methodology was led by Cătălin Lungu, Professor Cătălin Lungu from Technical University of Civil Engineering, Bucharest. It's my colleague and my friend at the same time. And we try to show the necessity to implement such a study in Romania and how to do that. And regarding with the Romanian methodology, the non-renewable primary energy, it's 8.4 kilowatt-hour per square meter per year. Renewable primary energy, it's 75.5 kilowatt-hour per square meter per year. The total primary energy kilowatt-hour per square meter per year, it's 65.9. And the percentage of renewable energy, it's 85.25%. Equivalent emission index in CO2, it's 0.9 kilograms CO2 per square meter per year. We simulate and we calculate the energy certificates for this building. The first one is in the pre-renovation energy performance states. The second one is the post-e-safe renovation energy performance states. And the third one, it's the post-renovation according to the Romanian methodology. And we find that we can improve with the minimum requirements for the NZEB building with the minimum requirement in our methodology, we should improve, and we show that having the building in the A category from energy performance point of view. What is co-design? The word co-design refers to a participatory, co-creative and open design approach where buildings and users directly collaborate through the entire design process with design experts so that can together identify the best design solution with a common framework. The co-design, why it's important, the co-design? We can see for designer point of view and for end user point of view. For designer point of view, the wider participation ensures that designers have access to users' knowledge and experience, achieve greater acceptance on the design choices. It is an opportunity to get the large public raising the interest of law fascinating. For end users, it is the moment to share their needs and knowledge on how to use the building, an opportunity to express their creativity. It is a collaborative process to make decisions on common spaces and or building maintenance. In Timișoara co-design process, it's happened in 3 steps. The first step was the knowledge, Here are the three energy performance certificates, and after that, what is co-design? Why it's important, the co-design, and the 3 steps to implementing the co-design in Timișoara. The knowledge phases, the training phase, the knowledge phase, the training phase, and the co-design phase. And the knowledge phase, it's happened meeting with local partners and urban stakeholders to define dates, working tools, methodology, and goals to achieve with co-design. The training phase, suppose the training with the school teachers on co-design to make them part of the working team. And the co-design phase is 4 workshops with the end user, which was the students, the teachers from the high school, urban stakeholders to address structural, architectural, and thermal issue of the buildings. It's happened in 6 meetings from December 2022 to March 2023. 20 students was involved, 5 professors, representative of Polytechnica University of Timișoara, where I am associate professor, from other invest, it's the regional development agency and the Timișoara municipality, which is the owner of the building. And the working, it's happened in a multidisciplinary teams. We explain to the children, to the students, what means created and the concept of created, which is a sculpted female figure serving as an architectural support in the place of a column or a pillar. Its purpose in architecture is also decorative. We have some image from the workshop session when the students and teacher were together with us and they knowing the building, they propose themselves how to refurbish the envelope, and they try to understand better how the school the life in the school could be improved. You see here the different simulation. The next one, it was a session dedicated to indoor comfort, when we explained to the students why it's necessary and now it's mandatory in Romania for the school to have ventilation. Even if we refurbish, it's mandatory to have ventilation. What means the ventilation? What means the insulation of the envelope, and which is the improvement of the life in the classroom. That means we explain, related with the indoor comfort, that it's necessary to install mechanical ventilation systems, to shade the southern facade to avoid the glue effect and irradiation in the summer months, to use renewable energy devices like photovoltaic panels. For the outdoor space of the school, we propose different area: relax area, reading and ping pong area, mini park, playground, state park in the school. There are different proposals for the area which we propose. Let's have a conclusion. It was an interesting. It is an interesting because it's still in working. This project, what we didn't realize, it's to apply the solution in the Romanian related with the Romanian law, because to obtain financing for this for such of refurbish, it's necessary to have a feasibility study according with Romanian law. It's a minimum requirement, and we try to find financing. We calculate it's around 2.5 million to realize the refurbish of this school. With this solution, improving the facade and also the HVAC systems inside, using renewable like PV panel. That is a collaboration between what is happened in Brussels, and we try next year to find the financing to finalize this project, especially from my high school from Timișoara. Thank you, and if you have questions, I'm ready to answer. Yes, please.
Now? Okay.
Thank you.
Thank you very much. It's, for me, impressive that in these times it's feasible to have this kind of projects. From my side, I have one question. Is eSafe commercial product? Did you develop it for these projects, or it is something that needs to be further developed for the further use?
It needs to be further used. The next step is the training with the structure engineers, with the mechanical engineers, how to know this solution and to implement this solution in their project, taking in account a seismic area, which is Italy and Romania. There is it's an important seismic area, and this kind of solution could really improve the life in the school or in the building, because we spoke about residential building also.
And second question, earlier in December I had participation in Architectural Congress in Belgrade, and looking at your presentation and the impressions that I am bringing from the architects, my question would it be possible to make some kind of synergy between architects and us, because we have lots of open topics which are only partly covered in their sessions and only partly covered in our sessions, and I don't think that we have enough synergy to fill the gaps that are probably very easy discussable things, and I don't see them being processed in
fact, how I said in the beginning, it's a holistic approach. This kind of project is supposed to have architects, structure engineer and mechanical engineer all together, and to propose a solution for a seismic area. That's it. And of course, the solution with this kind of panel and with the structure steels outside, it's happened quickly. We can quickly work and to have results.
Thank you very much.
Thank you. Other question? Yes, Maru. Please the mic, because it's good to be registered.
With the regulation, for example, if you're applying it in other countries, how do you make sure that it's applicable to other countries as well?
The solution it's in Romania. It's sure it's applied. Should be applied. That is clear, because it was the pilot buildings was selected. Having 60 buildings in the selection, and we promote this high school from Timișoara, and we were selected from 60 buildings. They try to take account about all the problems from the beginning. That means, first of all, to be a seismic area, and the second one, to refurbish from energy performance point of view the building. But the first things is to improve the infrastructure of the building, and that's supposed to have architects, supposed to have structure engineers and mechanical engineer, building services engineer, how I told before. It's applicable because it's according with energy performance of building directive, which in each country from Europe it's implemented, and also we through the new methodology we implement this solution.
Thank you very much, Professor Dobosi. I would advise that we continue with the next presentation.
Okay.
We invite Mr. George, I believe, Yorgos Bamblenis. Thank you very much for coming here. And Mr. George will present us Better to Predict Than to Cure, AI-driven monitoring platforms, hubs for optimizing machinery in reliable and availability. Thank you very much.
Good morning from me. I know that it's already late, so I'm trying to shorten the presentation as possible to save some time. First of all, I want to thank the organizing committee for this conference and exhibition, which gives to the industry and the people involved a very good opportunity to conduct and see things for the future. Few words for me. After 41 years in the Navy, I retired and now I'm running as president and CEO of a big shipping company. And I'm facing the problems of the markets as they are in reality. So the biggest problem that I faced in both my positions in the Navy and in the commercial market right now is that it isn't the product that we need to support, but it is the product that we have to maintain operational through the age. So this, in our days, it became very, very difficult because the resources are limited. The machinery is aging. A recent statistic shows that the average age of the machinery in the EU is between 17 and 18 years. That means that that machinery needs a lot of maintenance. The maintenance is expensive. The age is big, so a lot of spare parts are deleted, obsolete, and not existing anymore. And of course, there is a terrible lack of skilled engineers to perform the maintenance and keeping the machinery running. So the challenge is the right availability and the right cost, but how? The time between failures is increasing due to the age. The in-situ repairs are difficult because the companies had reduced the skilled personnel and the availability is not the wishing one. And of course, the time to restore is going up and up, and that affects seriously the production. So the problem, it seems somehow unsolved by few words, again, pushing the report. What we've seen is that the EU had recognized that that problem exists and needs somehow to be addressed and resolved based on the existing technology. And the existing technology for us on the fourth industrial revolution is the AI, the IoT, the computers, things like that. So the EU now is supporting strongly the health usage monitoring system, the HAM, as we say. What is the HAM? A HAM is a system that collects data from the machinery using IoT and big data analysis can collaborate those data and move the maintenance from the reactive to a predictive level. By moving the maintenance to that level, you reduce the cost because you are aware when it will happen. You can programming the spares and the technicians for that. And of course, you can arrange your production line in such a manner that will not affect the production in the end of the day. In summary, the objective of using such technology are those that you can see on the slides, and I will examine each one of them in details straight immediately. So, to provide advanced health monitoring and critical equipment using AI, what is the benefit of those? First of all, you increase the lifetime of your machinery by providing a very good feedback on the problems that can be occurred, so you reduce the maintenance. By foreseeing what is going to happen, it is very easy to program your maintenance in a manner that allows you to have all the necessary parts and skills on the table. And of course, you maximize the availability and reducing the cost occurred by an unplanned maintenance system. The second objective is to provide a continuous equipment status assessment. By using such a system that having all the data available from your machinery, it's very easy to see what the performance is, to estimate the methods that you have to run your machinery to make it more sustainable and increase the serviceability, and to have a quick damage assessment in case of something going wrong. Of course, it is the companies willing to provide the performance rates and the KPIs needed for achieving such a solution. The technical assistance, as I mentioned before, there is a huge lack of skilled technicians in the market. And of course, it's very difficult to train some because that takes a long time. So by using such methods, there are capabilities like a helmet with a camera on the top that transfer the view of the original machinery to some facility or some specialist in another place, and this specialist can give directions and rules to the technician that is present in the place to do the work without having the necessary skills, because just doing the hand job and nothing more. Of course, with such a system and with a forecast that you can have for your machinery, it's very easy to program your ILS system and to find in advance what you need and where you can find it. That saves a lot of time, because in the majority of the cases, the OEMs has obsolete the production line, and so you have to go to the market to see who has the capability to make the thing from the beginning for you with the same capabilities and materials, etc., etc. This is very good, because if you go and ask to make for you a cylinder for tomorrow, that may cost you about 5 times from something that you order in the proper time and you have it in your store for the time that you will need it. Of course, the management is very interesting on viewing the performance of the system and the forecast of its sustainability. So the systems, by the KPIs that are involved, can transfer in real time the situation to the management, and the management can programming the resources and the needs in order to keep the machinery running in a proper manner and not affect, of course, the production line. So in benefit, the benefits in summary, it's to increase the time between failures. That moves us from corrective maintenance to predictive maintenance, which is the future of the maintenance in our case. To anticipate and prevent evolving failures with the continuous monitoring and the algorithms that are embodied to the system, you can foresee what's going to happen and when it's going to happen with a very good level of accuracy. You can enhance the on-demand inside repairs without having to call the special technician in situ to do the job, because the majority of the case is far away. In terms of merchant navy, a ship can be in China and the OEM of the main engine could be in Germany. So you need to spend a lot of days just to find the right person to come and do the job. But with this method, by transferring the icon and giving a good view on what's happening and good instruction from the skilled technician, the problem can be resolved in situ without moving people from the one end of the world to the other. Because of the system, you can reduce the time to restore. You have everything in situ, planned. The technician is waiting somewhere in the world, so you can do it easily without extra expenses. And of course, you can increase your sustainability during normal operation, because the system monitors and warns you about possible failure in the future. Those systems were implemented in the military industry for years. With the AI techniques and the IoT have been improved a lot. Now they are very well spread on the merchant marine. There are a lot of companies doing such programs. They are tailor-made on the requirements of the customer. The majority of them are vendor agnostic, so you don't need protocols, just an exit to collect the data. And of course, in terms of cost, because this is important, from what I've seen, the most complicated system of that, it's about 1,500,000 euros. And in case that you get involved in an EU program, you can have both 70% of that from the EU. So that was my presentation in a short version. Thank you for your attention, and if there are any questions, please to try to answer. Yeah.
Do you intend to extend it to optimize on energy consumption, or you focus strictly to the maintenance?
No, it's already part of the case. Minimizing the consumption is perhaps for the marine industry the most willing asset of all the others. So yes, the consumption is a key part of that solution. Yeah.
I mean, AI in Navy should for sure have some limitations. Do you make it open?
No. The military solutions are not open. We use the military channel for communication, which are well protected and encrypted to cover that need. But in general, what you transfer is data that are not that important because of the machinery. You don't transfer data of the combat management system, of course, through that channel. Thank you. My pleasure.
Thanks a lot. Our next presenter is Mr. Vladimir Korać. He has interesting experience from Qatar, and one of the projects that he realized there will be presented today in the presentation named Realization of Separate HVAC Project within the Multifunctional Mega Project Oasis in Qatar.
I'm Vladimir Korać, author of this presentation, and firstly I would like during your reading of that abstract to ask, because I prepare my presentation in a Serbian language, but I can try to immediately to start presenting the speech in English. So I don't know, are here attendants mostly English-speaking ladies and gentlemen, or Serbian-speaking? English? Yes. Okay, anyway, I shall try to do my best and not to disappoint you. So, let's start. I hope that you already read, you have already read this abstract. Actually, a presentation concerns one huge, mega structure project in Qatar, which construction started in 2015 and should last 4 years. I shall tell you what happened in order this to not to fulfill planned realization duration period. Instead of 4, it was 6 years construction period. But first, let me present that project. This is 4 460,000 square meter of net area, which is one very complex and nice project consisting of 7 units. First unit, was this tower, which you can see on that animation. This is animation, actually. In backyard is a new city, financial city center in the bay, Cornish Bay. But here you can see this tower. This is a 5-star hotel, which was planned as the first 7 years hotel in Qatar. Actually, on the world, there are only 2 or 3 7-star hotels, all of them in United Arab Emirates. But due to certain circumstances, that hotel stayed at 5 stars, fair enough, I think. That oval-shaped structure, which you see in front of the hotel, is actually Oasis, upon which the project was named. In the street level, and the next 2 floors is shopping mall. Ground floor and 2 floors, and 3rd floor, which is technical floor for technical facilities. And as from that level, or the roof of the shopping mall, is a residential area, consists of 7 segments, ellipsoid shape, with a couple of hundred of apartments, duplex and triplex, and normal, with parks and green areas on the roofs. Also in the middle of this ellipsoid shape is a park, practically. Park is actually in the same time roof of the team center, team park, which is under this park, and park, which is in the middle of ellipsoid shape, has a 26,000 square meter, and there are many trees, some 130 different and rare trees, and bushes, and paths for people walking, etc., etc. Also, we have Simplex Cinemas Center, and underground four levels for car parks, and for technical rooms for facilities, and etc. Sorry. Third slide shows in reality how it looks, this area, this project, Oasis, but this is a view towards Al Khalij Boulevard, which is behind the hotel tower. Hotel belongs to famous La Cigale brand, which is similar as, say, Hilton or Sheraton, but this is most familiar to people living in South Asia. I mean, people which are from say, Malaysia, Singapore, etc. They know very well that actually this is French brand, but this is combined with one brand from Malaysia or Singapore. I'm not sure. In the middle of a park, you can see 2 towers which are connected with a team center, amusement park practically, which is under the floor of the park. And in one of those 2 towers is the beginning of a roller coaster, which will practically drop from some 40 meters height. Actually, 20 meters is tower above level of park, Oasis Park, and another 20 meters down to the street level. Altogether is 40 meters. Now, concerning some data regarding that project, supervising and consultant was an e-com company. The main, contractor is Redco Construction Almana, Doha, Qatar, domestic company, actually domestic and international. Subcontractor for mechanical, electrical, plumbing services is Conspel Qatar WLL, my previous company. I was employee of this company 3 years long, from 2017 till 2020. Location is Mushairib. This is an old city center of Doha, Qatar. Name of project, Doha Oasis Mixed Use Development Project. Main architect, main designer, Nabil Golam Architects from Lebanon. Structure Design Bureau, the 2D, Rodolphe Matar. As I told you, it was planned to be completed by 2019, after 4 years, but it was completed after 6 years, 2 years longer. Useful net area is 460,000 square meters, air-conditioned and ventilated area, but a lot is 73,000 square meters. A planned value of the investment was 60 billion of Qatari reals, or 1 billion and 500 millions of US dollars, but it was due to circumstances much bigger. And what were those circumstances? I shall explain you later. Those are my photo made by myself in the during construction stage. First, picture number 3 is a complex Doha Oasis, view from Al Khalij Boulevard. In the front is a shopping mall. Above it is, apartments, residential area, and behind is a hotel tower under construction. Picture 4 is very interesting, showing construction of team park, team center, which will be under the roof or under the floor of oval-shaped Oasis Park. You can see in those white, 1 second, I shall draw your attention. White trees, columns, which are in a basis in diameter of 8 meters each, and the capital are branches which are keeping, there are 9 or 10 like this, are keeping grill, a huge grill, which supports a curva, a trapezoid type of stainless steel plates imported from United Kingdom, on which was laid a concrete floor, practically, of the park, which is above. One very, very interesting construction by all means. Now, next slide. Regarding some challenges and regarding ecology, sustainability, etc. Problems here were on the first place embargo against Qatar, which took place in summer of 2017, lasted till January 2019, created by surrounding Arab countries. On the first place, the Kingdom of Saudi Arabia, Egypt, Bahrain, and United Arab Emirates. It was a family problem, actually, because Qatar supported Iran, Persia. They share a common gas field, huge, enormous, huge, in the middle of Arab Gulf or Persian Gulf, how we Europeans used to call it. But Saudi Arabia is against Iran, Persia, and etc., etc. In one period, it was very tough because it was threatened that Arab countries will attack Qatar, but Qatar got in contact with Mr. Erdogan, Turk president, and he got their protection. Long story. And those countries, they gave up, but all this complicated the construction of one such mega structure, and so, I mean, huge project regarding, because say 80% of equipment and materials was imported from abroad. Everything this came finally in Doha, but very slowly with different prices, and this everything complicated to us construction, because I was a construction engineer, site engineer. Firstly, I was in engineering department where I created this small but very, very interesting design. And later, by the end of that's my first year, I was a site engineer. And I remember that when material arrives, all specialities concentrated to one small area in order to catch up with planned time, to mitigate time delay in construction. And it was terrible, and it was very dangerous in order not to be, I mean, accidents on the work, and in order to mitigate, to minimize such situation with possibility of wounding people, of accidents. Management introduced many new, very qualified safety engineers. Say in an average on the brigade of 20 workers in one moment on the site were 5,000 workers. You can imagine 5,000 workers in the same time. And with the measures, like for example, every morning I was a witness of this. Each foreman was, I mean, directed to keep toolbox meetings, so-called toolbox meetings, with his brigade of 10, 20 workers to remind them regarding personal protective equipment, regarding safety at work, regarding scaffoldings, regarding this, regarding that, and everything that this was supervised and by site engineers, as I was, and by safety engineers, very qualified. So, and the goal was zero accident. And they, not only on that construction site, but on other, all of companies and management which specially supervise and made project management, they put with huge billboards, we have zero accidents, so many days we already have, but no accident, or some minimum accidents without casualties, etc. Also, a problem was with the high temperatures. So this is in the summer. There are two practically seasons. Hot season, as from say beginning of April by beginning of October, and cold season. During hot season, temperatures, in spite of the design temperature as per Qatar construction specification, is plus 47 degrees Celsius in shadow. We reached, you shall see later on some slides, and 49, even and 50 degrees Celsius in shadow of air. And when temperature rise above 43, it was forbidden. Each brigade of 20, say, workers, they had cooled water and access to cold water for drinking. They decrease working shifts instead of 2 or 8 hours, 3 or 6 hours, and interruption between 11 a.m. till 4 p.m. with the third shift working at night. So it was a must and obligation to organize work on that way, and we survived. Regarding sustainability and economic and ecology, one of design was such that we had 4 levels underground. So underground means that one huge part of the project was protected by severe hot temperatures during summer. Measures were planned for to minimize spend of electrical energy, spending of drinkable water. Also, one of measures which later actually this huge project was equipped with a couple of cooling stations with turbo chillers and air-cooled and water-cooled cooling towers. But later, actually 3 years ago, complete this project was connected through the 2 energy transfer stations to district cooling, which is administrated and organized by a public company, Qatar Cool, which is you shall see later with capacity. All capacity dedicated to that project is 12,000 cooling tons or 42 megawatts. Actually, that project needs 36 megawatts, but there is a certain reserves for later. This is planned to enlarge some and to connect some additional parts nearby. For construction, we use materials which don't damage environment and which emit very minimize quantity of CO2. Natural ventilation was used in a cold season between October and March. In this case, also energy was saved, electrical energy, etc., etc. The project got certificates for sustainability and also certificates for green construction. Green buildings. Now a little more regarding design for 2 tunnel type glass bridges where I was involved. Actually, those are my HAC projects. One German company made a design of structure and architectural part of those bridges. Each bridge, there are 2 bridges in question. That picture number 5 is animation. Picture number 6 I made during construction, showing one stage of construction. The only floor is, say, of concrete, but side walls and roof are of glass. Each bridge is between, one bridge is 20 meters long, another bridge is 21 meters long. Your far right up is a cross section. The bridge is, say, from outside 3.5 by 3.5 meter, and connects first floor, but this is very high first floor of the hotel with second floor of the mall. One is a boulevard bridge, which is closer to Alcalij Boulevard, and another which is under 90 degrees, connects also mall, but part of mall which is practically converted into the spa center. This is a view, a picture, my picture also, which I made, one of those two bridges during construction. Actually, a German designer, he made estimation of of cooling load. And he calculated per bridge approximately some 14 kilowatts needed cooling capacity in order to cool and to cover all those heat gains of summer and of transmission, etc. I calculated 34 per one, 33 per another bridge, meaning that with the 13 kilowatts, I would get, when outside is design temperature of 47, this is that yellow bar down, that we could get 36 degrees Celsius in tunnel bridge, not less, but with the 34, this is a blue color bar, we can get, design 24 degrees Celsius. I can explain later, because now we have no time, why he made a mistake in his estimation. This is one isometrical presentation of two bridges showing actually I designed 3 subsystems. The first subsystem for air conditioning is cooling by cooling floor radiant cooling with cold pipes in a concrete floor, in one of a layer of concrete floor. Another subsystem is air conditioning with fan coil, trench type fan coils, which were in trenches along the side glass walls. And third one subsystem, which is shown here, are systems for keeping overpressure, positive pressure, because we will lose air. Actually, we have infiltration. We have infiltration on the spots, on the ends of bridges, here and here, similar as a finger for entering the aeroplane on the airport. You know, this finger is not sealed to the plane, and through the slot gap between plane and finger. If we don't keep overpressure, we have infiltration of, you can imagine, 47, 50 degrees Celsius in shadow temperature, which is so with this overpressure system, I kept a positive pressure of 50 pascals, 5 millimeter of water column, And in case of that disturbed is a positive pressure field inside the tunnel, which were approximately between 200 cubic meters, 250. I supplied 1,000 cubic meter of fresh air, and from breathing is important, and for keeping of positive pressure. Another system directed extraction of air to minimize this up to the zero extraction if necessary, just in order to keep positive pressure in all the period during day. Next is a scheme of cooling and heating. Those bridges are shown as that this is in a layout, say, but you can see in each are 8 and 8, 16 in-floor fan coils and cooling grids which are in concrete for cooling the floor. And here is one small substation which is actually was designed in the and located in the one substation in the hotel. This is hotel. This is layout of hotel, first floor. But under this first floor is medicine and technical floor, and under this is a huge lobby which is some 10 meters high. So. But in any case, this is complicated because, I mean, those two bridges were inclined each some 8% slope was this due to which I prepared some additional measures against dew point and a danger of this is how it looks like. This picture shows myself when construction was nearly completed in August 2019. Picture 13 shows I mean in-floor fan coils, and on picture 14 are fan coils actually nearer to the side walls. You can there is a air supply, jet flows along the glass wall, and second half longitudinal of a fan coil extracts air, recirculates air from the space. Picture 15 is animation how it looks. This is in the first site, sorry. Where is this picture? Jel možete nešto da vratite? I am nearly finished. Malo unazad samo, ako može još jedna, evo ga. And picture 15 is in nature how it looks when it was completed. Also, this is Boulevard Bridge, which is 20 meter long. 21 meter is Spa Bridge, which is the next. And I shall complete it. This is one of substation with air handling units. Major, generally, was Euroclima from Italy. And interesting is slide number 18, showing temperatures, which I made, screenshot in July 2019. July was under temperatures. For example, with different towns in the world, you can see Tokyo 18 degrees. This is 2 p.m. There is the Silicon Valley in California and the United States. Dubai, Belgrade, Amsterdam 18. So Doha 48 and Al Rayyan. This is the municipality on the outskirts of Doha, where is the student campus and universities and educational city stadium project, which next one on which I'm on engaged. 49, you see, but design temperature is 47, and 50 degrees. This is temperatures in shadow. Dry bulb temperature in shadow of air. And here is some description regarding other facilities. Some interesting projects also I would like to draw your attention. This is financial center, which is 2 kilometers or 3 away from that Doha oasis. Here are huge banks in those skyscrapers, also powerful Qatar gas company. On the slide, on the picture 20 are the new stadiums in that time new, constructed for FIFA 2022 World Soccer Championship, Football Championship. This is metro. They constructed 3 lines of metro within a 5 years period. And the first line, red line, was inaugurated in March 2019. And I like this metro because this is especially protected against suiciders, etc., with those, barriers. For example, when an automatic train without operator comes, first opens a gate in front of the train, and after this opens the gate of the train itself, and nobody can be killed. I mean, very, very good and modern concept. This is one also building in shape of Arab swords, which is partially hotel, partially residential area, and then some administration offices, etc. And here is used literature. Thank you for your attention, and sorry for a little longer presentation.
Thank you very much.
It lasted longer because I was not prepared to translate this immediately in English, you understand?
You managed.
Thank you.
Your projects are always extraordinary, and can you get the mic, please?
Yes, please. Do you have some questions?
Yeah, we have questions. Your projects are really extraordinary, and we discuss very frequently about this experience, but I have one question now for your hotel building. There was lots of greenery on the top of the building and also on the facade.
Yes, correct.
I strongly believe that it was quite a challenge to put the HVAC equipment somewhere. Did you do it decentralized floor by floor, or did you have any central point for the centralized coverage of HVAC?
So, all those, trees, etc., which were on the facade of the hotel tower, and also in Doha Oasis Park, which I showed you in the middle of the ellipsoid oval. They practically were exposed to the severe weather conditions there. This is one, interesting story because, this country has fortune and much money. In Qatar, this is a cultural village, actually, in a neighborhood, one part of town for different artists, etc. Whereas there Philharmony in one building, and one street is sidewalks are air conditioned. So you step on the part of the street which is for vehicles. 49. You step here on the sidewalk. There are floor grills. 28. Just imagine. And they threw away practically energy. Okay, this is too much, I think. But this is improvement. How also stadiums.
How they manage the thermal shock? Because for the human body, it's a thermal shock.
Sorry?
How they manage the thermal shock? Because for the human body, it's a thermal shock from 49 to 28.
So somebody who lives, for example, shopping mall, which is also here behind, which is air conditioned, on say 26, for example, if outdoor is 47, he will step on the sidewalk. Where is 28? So very good. And nobody will be impatient to walk along the main street where is traffic with cars, etc., etc. Also stadiums. All stadiums were air conditioned, even pitch for playing ground was air conditioned, but on the height as from zero level, where is grass, to 2 meters height, with the jet, so that outside when it's say 47, in the area of playing, where players playing soccer, football, is between 28 and 30, and all those areas where are attendees and the fans was air conditioned to 26. And outside, roof is open.
Mr. Korać, it's clear having such a project, it's something unique in life. From professional point of view, it's a challenge. Yeah. And we want to congratulate you for this project. And it's clear that should be presented to the young generation also. It's important. Unfortunately, we don't have the students here, but if you have the possibility to present this project in the university, could be very useful for the students. That it's clear. Yeah. And we want to thank you for your presentation. You have a diploma of attendance for this Congress, and now it's time to invite our chair colleagues. Just a moment to have the title of the presentation. Thank you, Mr. Korać. Yes, I invite Petar Petrović, my colleague from Czech. Please come near to me to be together, or you want to see the presentation. Petar will present Beyond Carbon, risk and opportunities, and the floor is yours, Petar. Thank you very much for being today with us.
Thank you very much for the opportunity. Once I read somewhere that one time UK Prime Minister, I think that it was Gordon Brown, visited one prison in UK and said to the audience, to the prisoners, "Oh, it's so good that you are here." And I'm doing something similar now. I was expecting some more public officials here to maybe tease them a little bit, to present them what are the current trends and developments in our segment. Unfortunately, not so many of them, but I will still need to present the same thing. I hope that it will be interesting to most of you. Of course, any questions are welcome. So I was thinking of some questions to be asked to all ourselves, and the most important question for me is: are we sure that we know and that we are aware where do we go and how do we continue? My question. Can I control it from the laptop, please? Okay, my question is beyond carbon or beyond life? What is our idea and how do we like to continue? We have mostly all the data available. We have even engaged artificial intelligence to help us with many things, but we are still failing to answer the simple questions. Since last few years, starting from COVID, we have some things which are making us very, very sensitive to the environment, and we involved uncertainty to be our present day, and we have many challenges facing unpredictable changes, being aware of climate change, so of all AI and technology disruptions, overpopulation, pandemics, but we are very slow with responding these things. 3 years ago, I made this slide, and I am repeating it today, where I stated one of the things that I stated was that war was not the last option any longer. And since that time, we have many big wars in Europe and in the world globally. And all this is slowing down most of the procedures that we are facing and also very negatively influencing our segment development, especially related to slowdown of fossil fuels, of application of new renewable energy sources and solutions. And from that point of view, I'm again sharing slide, which is very new, published by World Economic Forum, which stated that since 2022, we have two wars that were influencing also economical growth and also development in our segment, giving to us unsafety to have energy security, to have energy costs booming, not controlling most of that things. And we didn't learn from the first war. Now we have the second war, where global debt is hitting the record of $307 trillion US. I don't want to go through all these details, but it's clear that we have to do something to wake up and to start thinking about that things. We have still bad dream. We reached some milestones. These milestones are, of course, very nice to be presented, but we have missed opportunities which are on daily basis are giving us a very hard position to recover the time that we are losing to reach the targets which are related to our segment. I will give you only a few hints here. Emissions are not declining at the rate required, despite policy innovations, increasing global consensus, and growing the private sector commitments. We did all that, but we don't get results. And getting nice procedures, making this in the nice, fashionable way is a very nice thing, but not getting results is something that should really worry us. Fossil fuel demand continues with previously anticipated peak that came in late 2020. We know it, but we didn't do much about that because we somehow non-verbally agreed that this top value in 2020 is now in the 2020s becoming decade-spanning plateau. So we keep the fossil fuels on very high level to 2020, and we don't do much about that. We speak about nuclear energy, we speak about transition, we speak about scaling up critical materials, but the result is again that fossil fuels remain on the high level plateau. If we see the current progress, which is not in track, we will easily see that by 2020, all the milestones that are set needs to be scaled up with 5, 6, 7, 3, 4 times. Do you think that we can make it? I don't know. We will see how it will develop, but in the moment, our position is really not so good. We have very important global consultant company, McKinsey, which made the research and that still is giving some expectations. Projected global temperature increase by 2050 was supposed to be 1.8 degrees. That was sustainable transformation milestone. Now, in this year, in 2024, we got two very nice named continuum momentum and slow evolution, which is warning us that this wouldn't be so realistic and that we can expect temperature growth for 2.2 Kelvin or 2.6 Kelvin. This is officially presented data this year, and that means that our Paris Agreement or whatever agreement that was present before will probably not be held by 1.5 or around 1.8, that we will need to scale up also these figures. Since that is happening, we had last year in Dubai UN COP28 climate conference, which presented results, and the result of all this, what was said there, is that we should now triple increase of global renewable capacity by 2030, and that previous 40% target for renewables is not only unambitious, it's also outdated. We speak now with 50 or even more than 50% of EU renewable energy share in 2030, and we speak about minimum 60 million heat pumps in year 2030 to be able to really follow all these targets and milestones that are set in regard of environmental focus. These are some words of coming to the action. I presented also some targets that European countries made, and we see that some countries are really developing very well, but most of the countries are underperforming, and this is the case in most of Europe. Uncertainty as normality. We are facing that since 2022, we have a gas issue, which is not anyhow resolved. The decision that was made a few years ago is that the gas is going out to be phased out, and that eliminating fossil fuels and transformation to efficient renewables-based power sector by 2035 should take place. And then it was announced that there are 9 measures to eliminate Russian coal by 2025. This didn't happen, and the new target is now that the phase-out trajectory for fossil fuels for coal is that it should be out by 2030, and for the gas, we speak about 2035. We speak about serious plans, and something needs to replace this energy. Since something needs to replace the energy, we are speaking how to do that. We have this year, this is 2024 data, minus 19%. That means that fossil fuel is really reduced by 19% this year. We have 44% record share of renewables in European community, and we have record annual growth in wind generation by 55 terawatt hours in 2024. This is okay, nice information, but we still have that 2023 was second hottest year in history in Europe. We had that record fall of EU power sector emissions, which is very good information. That are positive things, but the result, again, is not coming to the point that we were expecting. Since that is happening, we made some targets like net zero targets, like crucial transition technologies. We speak about low carbon technologies. We are presenting huge investments, but if you see what is currently invested and compare it to what is needed to be invested, there is a huge gap. We should find a way how to close this gap, that we are sure that all these targets are at least realistic to happen in some close future. Again, I did some research investigating what is the segment situation, and in most of the cases I was finding challenges to achieve this energy transition in the proper manner. If we start speaking about all the challenges, that is a very long story, so I will leave it in the presentation and whoever is interested can read it, but I will focus on some things that are important. By 2050, we must low emission power generation capacity increase by 10 times. This is clear target to be able to reach other targets. We have some targets also which are not related to HVAC. some of us are closely related to that, like electric vehicles, that we need 30 times increase up to 1 billion by 2050. Decarbonization of Big Four, that is also interesting to be connected to Professor Dobosi presentation. We speak about the carbonization of 4 big industrial material pillars like steel, cement, plastics, and ammonia. This is targeted to be really watched very carefully, and your presentation was very interesting to me, and I was happy that these things started in Romania. I hope that we will start them in Serbia as well. Buildings, similar things, raw materials, again, similar things. Hydrogen and other energy carriers, of course, is very important for all of us. I will only shortly touch the base for Serbia because we didn't do so much, and from that perspective, I would like that we really wake up and do something better. We have still coal power generation at more than 60%. We have hydro at 24%, which is historical, and that is good for us. But in the final result, it's only helping to have picture a little bit nicer. But in general, we have 60+% of coal, and that is bottom line, which we really need to be aware of. Coal is announced to be phased out by 2050, which is very long procedure. 15 years after European targets. I don't think that it can be held like this, but at the moment that is the information. National protocols are not clearly defined, and from that perspective, still lots of work to be done in Serbia. Clearly, we need to change something. My research was focusing on the international and global reports and protocols that were made to reach the targets. It's clearly that on global level we need at least 450 terawatt hours more renewable energy by 2030. And what is going on in Europe is that last year we had decrease of sales of heat pumps by 5%, which is the result in 2023. I think that at least this is European Heat Pump Association information. I hope that it's correct. This is absolutely not clear to me that with all this, what we saw, we have the down-performing increase of number of heat pumps in Europe. To be on the level in 2030, we need to have 17% growth year by year to catch the numbers. I don't know if it's possible, but we have to do something to get this possibility. As I said, it's expected to have 60 million heat pumps in Europe by 2030. This assumes that 3 million jobs will be created, that heating bills should be at least 20% lower, that 46% fall in CO2, 40% decline in NOx emissions, 2.5% higher GDP, 60 billion saved on energy imports, and gas demand in buildings falling down to 40%. Very nicely said, but even if there would be a clear will to do that, there is not enough manufacturers of heat pumps to achieve these numbers. So there is a trend to push local manufacturing capacity, to motivate, to get incentivized, to have possibly increase of sales. Now coming to the topic which is interesting to us, HVAC people which are interested to go in that direction, we see heat pump as a central player in most of market segments like industry, cities, urban districts, new buildings, existing buildings, apartment buildings, commercial buildings. So generally we see potential to cover all this with the heat pumps. And heat pump philosophy is something that I would personally see very important, that is closely followed to be able to reach these numbers that we spoke about. Aligning to ambitious standards and commitments towards carbon neutrality, countries seeking an energy transition to cope with stark reality, focusing on climate crisis and surge on demand for heating and cooling to meet demand on large-scale heat storage. Meaning that probably the biggest consumers in civil construction areas are coming from us, from HVAC, from heating and cooling. Since the demand and the production are not synchronized, there is a new trend to make not only electricity buffers, electricity storage, but also heating and cooling storage to be able to leverage and to synchronize between production possibilities and demand possibilities. The key challenges in energy transition that I tried to locate during my research were to achieve heat electrification, to utilize existing thermal power plants, to meet demand for large-scale heat storage, and to eliminate final 10% emissions. The first thing is clear. We should replace all the gas-related or whatever related electricity production. Second is very interesting to Serbia. We have very widely spread district heating possibilities, and I think that this is also very useful potential to use it to create very easy way to change from fossil to renewable energy. Storage, as I explained before, also very important. Coming to the electricity point, fossil fuel-based thermal power plants needs to be replaced by renewable electricity generated by solar PV, wind, or some other solution. The energy conversion efficiency of the most power to heat conversion thermodynamically falls below 1, so the heating cost will never be lower than electricity costs. Meaning electricity as the source is probably the best possible solution in the moment, especially if we manage to transfer it from the fossils to polyvoltaics or wind energy. Large amount of waste heat, this is our focus, we do it in our projects with energy efficiency focus, is produced in industrial processes, and ambient heat derived from the nature is very yet fully utilized. There are loads of terawatts produced by industry which are not used, that are going to the atmosphere, creating environmental problems, and not used for recovery or whatever type of energy consumption utilization. In Serbia, we have extraordinary potential for that. Existing power plants, I mentioned, I don't want to go in details, but we can use them as a buffer. Previously, we used them as an energy manufacturer, but now we can change philosophy to use them as a buffer, to have transfer of energy, electrical energy, through the heat pumps to the consumers using existing power plants as thermal storage for that purpose. And coming to the thermal storage, of course, extremely high importance, because lots of energy is being missed or thrown away because it's not used in the moment that it's produced. So this is, according to research we made, next very big trend to have thermal buffers, thermal storage possibility to have more convenient utilization of the energy. Of course, we speak about biomass, and personally, I always, whenever I have something to say, I say, I don't want to burn our forest to have energy. This is my perspective. We have the heat pumps, we have solutions to power the heat pumps by electricity. Why should we cut the trees to heat ourselves? I really don't understand that point. Legislations, clear to everybody, most of them are done, but very few of them are really followed. For the heat pumps, after the legislations, to be able to reach the targets, we need to bring the heat pumps being affordable for all segments by having some activities done by lobbying, by promoting, by discussing. I think that our conference, that was what I said in the beginning, is really needed to be shared with some decision makers to realize what is the status quo to do. For the capex, we need subsidies. For the fossil fuel, we need to stop the subsidies, to make the preferred interest rates, to make easy administration, local production, this was what I mentioned, under local GDP, to increase the volumes Heat pump is not rocket technology any longer. I'm sure that making them locally to increase the possibility to cover these gaps would be very, very interesting and nice possibility. Operations, OPEX, low electricity gas price ratio. We need to provide and to promote benefit of using electricity, variable electricity prices to make some incentives for people that are using the electricity for this purpose, new business models, low electricity taxes, and of course CO2 prices when somebody is deciding to be dirty still, to be in position to pay for the CO2, not just to escape any responsibility that he is damaging our environment. Company-based Scope 1, 2, 3, I don't know if you are familiar with that. Scope 1, 2, 3 is very easy and nice idea to push the CO2 neutrality to the companies. We are consulting many companies in Serbia through Scope 1, 2, 3, coming to the point that the utilization of heat pumps is a key and the best solution for that. Any details we can, of course, share. Industrial heat pumps, there are many manufacturers that are producing heat pumps that are giving heat temperature up to 120, 180, even more than 200 degrees. I don't see any reason why the heat pumps would not be used industrially more. I will just give you a few hints what we did in Serbia. Serbia is one of the slower countries, but from the other side, in some cases, we are not so bad and even faster than Europe. We have Continental factory in Novi Sad, which we collaborated also with Mr. Korać to some extent. We have heat pumps that are replacing the gas boilers. The need for that was that Continental was pushed by mother company to become CO2 neutral in a short time, and now we are also happy about that because this is our potential, but it's very good that with these kind of big projects, we can engage our knowledge and our products that are available on market to be able to resolve such things. Similar thing we did in Henkel in Kruševac, where we used the integrated units with heat pump integrated for the preparing of the air, which is used for heating, cooling, and ventilation. Packaged units which are doing the thing and making a very efficient HVAC procedure. We also made improvement on Sava Center in Belgrade distribution air system, minimizing consumption of metal, reducing all these CO2-related factors on production or installation. And now we have very clear ceiling with very successful and good distribution of the air. We also have a project we made together with IKEA, where we used also packaged units with integrated heat pumps using thermodynamic recovery, having extremely high seasonal COP and EER to provide energy to IKEA retail park. We are very much focusing 4-pipe systems which have a possibility to generate one of the two energies, let's say, free of charge. On the cost of the heating energy, we get cooling energy, or on the cost of cooling energy, we are getting heating energy. I can give you some details of a hotel of 100 apartments during the summertime had electricity account of 2,000 euro. They are super impressed with that. They also have some solar heat, water heaters on the roof, so everything is integrated. It is possible. It just needed to be done through the design stage to have this kind of very nice solutions. And similar with other projects, I don't want to keep long time with that. So this is what we are doing. This is how they are doing, how we are thinking. And I think that it is really final high time to make some wake-up communication to try to bring the things back in the controllable manner before we lose the time for that. I thank you very much for opportunity to present this to you.
Okay. Thank you very much for your presentation. It's really an overview what it's happened in Europe and what it's supposed to happen in Serbia also. I saw the references which you have. I have the question, what do you consider these targets are achievable, it's realistic, or too courageous?
I will try to put it in diplomatic words. I am sure that they are achievable,
Yes.
but I am also sure that they will not be met because they are achievable if everybody will do the synergy. I asked you, do you communicate to the architects? I asked the question why public officials are not here. It's not enough that we speak. I think that we all know this, what I presented. This is not any special knowledge. This is available in any, I don't know, few weeks research, you get this data. But this data is not communicated openly, and I don't think that people which are responsible to get decisions about that will get this information. So shortly, I don't think that the targets will be met.
Realistic speaking, we between us, the professional architects, structural engineer and building services engineer, we are in contact and we discuss. The problem is the politician, how they promote these ideas, because it's not so easy. Maybe they don't understand what we speak, our language. This is another problem. Cătălin also can tell, because he is very familiar with what is happening in Brussels. I saw you are the representative of Clivet in Serbia. We visited Clivet this year. In Italy, we are impressed. Clivet was one of the main sponsors of our conference this year, and we expect them also next year. I have another question. When we come back in Sava Center to organize the Congress, because 20 years ago, it's happened there, and I was very familiar from 3-4 years. Yes, I saw the works are very advanced.
The works are done, and I would be more than happy, because our solution for the heating, cooling, and ventilation is there, and we would be more than happy to present it. But
it's a good reference.
It is very good reference, but to tell you the truth, also there I am not so big optimist, because I spoke same question to the organizers of the Congress, and if I tell you that difference in renting the area here and there is
it's expensive.
Really big. I think 5-6 times different.
Okay. Anyway, we feel very good also here that it's clear. And I am 20 years ago. I attended the first Congress in Belgrade, and I'm really proud that it's happened every year. Only in pandemic, it was only by online, but we are at the end of our conference, and I want to thank. If you have other questions, please, before to finish. If you have question, because it's a good reference also. It's what we present, all three here, it's very practical. It's not theoretical, and it's good to share. And for my point of view, that for students, it's good to share with the students, because it's what they need. Yesterday we had here the students from Timișoara, also are students from the 3rd year, 4th year, and they have the knowledge, the technical knowledge now, and they are interested what is happening in practice. And such a presentation, it's very useful. Question? Do you have? Yes, please. Please to the microphone. You need the microphone because it's registered.
Thank you very much for your presentation. I have seen there is a decrease of the sales of the heat pump in the EU. Is that all? Is that in Serbia or like Balkan countries? Do you have increasing, or you also have the same situation in the EU?
To tell you the truth, precise statistics are available for Europe. What we see in Serbia, at least, that we don't feel decrease, because there is Serbia is a little bit different. That I think that maybe our colleague from Riva can give us some more details about the European sales, because they are maybe related to some subsidies and incentives that were present before. In our countries, in Serbia, we don't have such case, so I think that the sales is more stable, but still not on the level enough that we all be happy. When it comes to industrial and commercial heat pumps, let's say big size heat pumps, we are sure that Serbia is growing, because we have, let's say in more than 80% of projects that we followed or participated in last years, we were selling or designing or introducing heat pump systems. That is what I said, that in Serbia we are maybe even a little bit more advanced than in Europe, which was strictly focusing or mostly focusing on gas, and only started to change this culture by the reasons that I explained. So in our region, I believe that the volatility of sales is not so big like it happened in Europe in 2023. I'm hardly waiting to see the results of 2024.
Thank you very much.
I can tell you that in UK, even with government incentives, the sale...
Take the mic, please, because it's registered.
In UK, even with government giving incentives, the sale of the heat pumps is gone down a lot.
What is the reason in UK to have this?
I don't know. It's the reliability.
Answer.
Yeah.
Went down because the energy price is still very cheap. And it was told before that the energy price will go up and very high, and it didn't happen, and that's the main reason. And on the other side, there is another effect of the heat pump prices. They were demanded at a high, let's say, proportion in the years coming after COVID, and the sales went up, and of course companies adjusted prices for the heat pumps, and that's why now we see that decrease in energy pump sales. So there are many influences coming from different directions. So energy price, then costs of heat pumps. It's very, very difficult to foresee how the future will look like. But in my opinion, I won't be so negative. And I can tell that at European level, in Brussels, there are two currents, streams. The ecologic stream saying that we have to be more demanding with the rules regarding sustainability, regarding the energy consumption and so on. And of course, there is the other stream, opposite stream, saying that there are too many rules for the market. It will be very difficult to accomplish all these rules. And that will put European products in such of, let's say, disadvantage. And again, we don't know the real answer, and we will see how the future will look like.
Thanks. Thank you very much.
Can I have the microphone, please? Stop. No, I 12, it's working. Okay, I want to say some words at the end. Thank you very much being for us. I want to thanks to our colleague from Prague for their hospitality. I mention everywhere and everyone in every day when I have the possibility to say that because really we feel very good here together, Romanian Association with KGH. We have more than 20 years of collaboration and we are happy to be here. We invite you next year in Romania. We have the 60th anniversary. This year was the 55th anniversary. We have the 60th anniversary in Romania. And we will be happy if we have a big delegation from Serbia. Because how it's happened yesterday, we had the students. Here it was a very good chance to have together Ashre and Riva and to promote the boats association, a global association, and we will be together in Orlando in February. And we negotiate to have a good memorandum understanding between Riva and Ashre in such a way that the professional to win and to have the possibility to disseminate all this kind of information. I want to wish happy Christmas, a happy New Year to all of you, and to see in Orlando together, I guess, Petrović to be there. All of you are invited, why not? Thank you very much and have a nice weekend. Yes, please.
Sorry to keep, but I would, Professor Marija Todorović was planned to be host to us today. She had some difficulties in the morning, and I would prefer to thank her a lot for all these opportunities, to appreciate what Professor Todorović and Professor Marija Todorović are doing for all of us. And we are greatly thankful for this possibility to be able to speak to each other, to exchange the ideas and the information. And I would like that there would be possibility one of the next occasions that we again sit together with them and that Professor Todorović will be host to us to run the things.
Yes, I want to say it's one of the reasons because doesn't work now it's work, okay, because Professor Branko Todorović and Professor Marija Todorović, Professor Bratislav Blagojević and the young generation, Marko Ignjatović, are our honorary member of Romanian Association. And once again, we want to thank all for this opportunity to be together. Thank you very much. If you want to say something? No? Okay. Let's go home.